In this video, we are going to discuss about interfacing of 16x2 LCD with MCS51 family of microcontroller, that is 89C52. In this video, we are going to use assembly language for programming the microcontroller. So before going into the details of interfacing of 16x2 LCD with microcontroller 89S52, let's have a physical look of the 16x2 LCD, how it look like.
So this is our LCD with 16 pin connector. The pin number starts from here 1, 2, 3, 4, 5, 6 and so on till 16. This is the back side of the LCD. You can see that the pin diagram is printed on the LCD at its back. Now if we place LCD like this, our first pin is this, that is ground. Second pin is VCC. Third pin is your contrast. Then the next three pins are your RS, RW enable, DB0 to DB7 from this point till this point. And finally your LED positive and LED negative. So first pin starts from here and the 16th pin is here, from up to down.
So why this LCD is called a 16x2 LCD? This LCD is called as a 16x2 LCD because it has 16 columns, 2 rows. So if we combine this, it will be having 32 characters. Now coming on to the LCD pixels. As we have already discussed, the 16x2 LCD has 32 characters to be displayed bifurcated into 2 rows. Each row is having 16 columns, that is 16 characters. Each character is to be displayed in this area as shown in the figure. Out of this 5x8, that is 5 columns, 8 rows. 5x7 area, it is fixed for the displaying the character. Any character, it can be ASCII or alphanumeric, any character. Now the 8th row, that is the last row, it is reserved for the cursor, and we will look into next slides that how the cursor is manipulated. So 5x7 is for displaying the character. LCD pins. There are 16 pins on the LCD from 1 to 16. LCD pin details. Now if you place the LCD as shown in the figure, then this is the pin header, which is 16 pin. Pin number 1 is this, and this is your pin number 16. The table gives the details of the pins along with their symbol and the function associated with the pin. We will take up the individual pin in detail. Pin number 1 of LCD is VSS or ground. It is connected to the ground of power supply. Pin number 2 is VDD or VCC. It is connected to the +5 voltage. So pin number 1 is connected to the ground. Pin number 2 is connected to the VCC. Pin number 3 is VE, or it is contrast pin of LCD. It is connected to the variable power supply through 10K of variable resistance. So you can see in the figure that one end of the potentiometer is connected to +5, other end of the potentiometer is connected to the ground, and the third end, that is variable end of the potentiometer, is connected to third. So third pin is used to control the contrast. By changing the position of this variable resistor, we can change the contrast of the LCD. Pin number 4, it is RS, called register select. It is connected to the pin number 2.5, that is port 2, bit 5 of 89S52. So port 2 bit 5 is connected to the RS, that is register select of LCD. Register select. Now the LCD is having 2 modes, command mode and data mode. When RS is made 0 through programming of 89S52, then command mode of the LCD is selected. If it is made 1 through the programming, then data mode of the LCD is selected. Now in command mode, the LCD, the data sent is used to initialize the LCD, while in data mode, the data sent to the LCD is being displayed on its front panel. Pin number 5 is read and write pin. It is connected to the pin 2.6, that is port 2 and bit 6 of that port of 89S52. Read and write. When R by W, the through the programming is made 0, then write mode of the LCD is selected. When R by W, that is pin number 5, is made 1, then read mode is selected, that is 0 means write, 1 means read. So we normally use write mode to the LCD. Pin number 6. Pin number 6 is enable pin. Enable pin is used to enable the LCD. It is a edge triggered signal from high to low. So a high to low signal is required to be given to LCD to make it enable. It is connected to the P2.7 of 89S52. Without enabling the LCD is not going to accept any data which is present on its data bus. So whenever the data need to be provided to the LCD, then a high to low pulse to enable the LCD is mandatory. Pin number 7 to pin number 14, that is DB0 to DB7, frames out the 8-bit data bus of LCD. Whatever the information, whether it is a command or whether it is a data, to be provided to the LCD, that has to be connected with the DB0 to DB7. That control signal will define that numerical value as a command or data, that is RS. Now the data bus DB0 to DB7 is connected to P1 of 89S52. Pin number 15 and pin number 16, these are the backlight pins of LCD. These are marked as LCD positive and LCD negative. So these are connected to the positive and negative solenoid, that is LCD positive is connected to the +5. This is, as you see, this point, and 16 pin, that is LCD negative, it is connected to the ground, as you can see this point. The LCD complete circuit diagram with 89S52. Pin number 1 is connected to ground, pin number 2 is connected to VCC, pin number 3 is connected to the variable power supply through potentiometer. Pin number 4, that is RS, it is connected to the P2.5. Similarly, RW is connected to pin 2.6. Enable pin is connected to pin 2.7. Data bus DB0 to DB7 is connected to port 1, that is P1.02, P1.7. and LED positive and LED negative, that is backlit pins, are connected to LED positive is connected to +5 and LED negative is connected to the ground. Commands. There are mainly 1, 2, 3, 4, 5. 5 commands need to be mandatorily sent to the LCD to make it available for displaying the characters. RS0 makes the LCD in the command mode. So 01 means clear the display. 06 means increment the cursor. Increment the cursor means whenever any of the character will be displayed on the LCD, the cursor will move to its next right position. 0E is display on, cursor blinking. That display will get on and the cursor will be in the blinking pattern. The last command in this table is 38H. 38H depicts that the display is of 2 lines and each character will be displayed in a 5x7 matrix. Although we have 5x8 matrix for each character point, the 8th row has been reserved for the cursor, which will be blinking with the command 0 is sent. Now the last command left is 80. So, as we have discussed that it is having 2 rows and 16 columns. So in each row there are 16 characters and each character is associated with the address. For the row 0, that is this row, the addresses are from 80H and it progresses to 8F. So addresses are 80H, 81H, 82H and so on, and the last address of the row 0 is 8F. Similarly, for the row 1, the address starts from C0 and ends at CF. So with this we can push any character at any position, and it is also one of the mandatory commands which need to be supplied. So the 5 commands which we need to be supplied are 01 for the clear display, 06 for increment cursor, 0E for display on and cursor in the blinking pattern. Anything that is 80 to 8F, C0 to CF, any where you want to push your character. 38 as 2 line and 5 cross 7 matrix display type. Assembly programming for the LCD. Now first define the RS, RW and enable pin. We can send a command to LCD. First of all, move the data, that is command, out of those 5 commands 0E, 01, 38, etc. to A. Then call a function called command write. In the assembly language, the function is called a subroutine. So we will address it with the subroutine. So call a subroutine command write. Now command write. As we have already discussed that RS need to be 0 for command. For writing, RW need to be 0. And enable has to be given a high to low with some delay. So clear RS, clear RW, set bit enable, move the data to the P1, that is data bus of your LCD, and then clear your enable. So this is high and this is low. High to low enable, clear RS means data, clear RW means write. This A called delay, that is, this is some delay which is used to provide some delay between the two operations. That is, if you are sending the two commands, then one command send, then some delay should be there so that LCD will be able to complete this internal operation, then the second command or data has to be passed. Now sending the data through the LCD. The data is the pattern which need to be displayed on the front panel of your LCD. Now send the data or move the data into the accumulator. That is, we are moving A, that is to be displayed on the, then call the subroutine called data write. Now data write. A called delay, as we already discussed, to provide a delay between the two operations. RS, set bit RS means RS equals to 0 means data, clear, that is write operation to the LCD, set bit, high enable, move the data to the port 1 where the LCD data bus is connected to, clear the enable, that is low, high to low enable, set bit RS which means data, clear bit RW which means write operation. This is the complete code for interfacing LCD with 89S52 to display I Love My India on LCD. RS is connected to P2.5, RW is connected to P2.6, enable is connected to P2.7. This part of the code sends the command. This part of the code is the command write, which makes the RS, RW and enable as per the command definitions. Similarly, this part of the code sends the data, that is I Love My India, and this part of the code is data write, which sends the RS, RW and enable as per the definition. You can see that here the RS happens to be 1 and here the RS happens to be the 0 as per the definition. Now this part of the code is delay, which is required as it is mentioned in data write and command write both. The delay is required between the two operations so that LCD will be able to complete its internal operation before the second operation could be passed to the LCD. For example, if we are sending I Love India, so by sending I, after sending the I, we should wait for some time so that LCD will be able to complete its internal operation related to I, and then space character should be sent and then L, O, V, E, so on.
Okay, this is our board. This is port 0. This is port 1. Port 2. And this is port 3. So port 1, port 3 on the left hand side of the IC, port 0 and port 2 on the right hand side of the IC. So as per the program, port 1 is my data bus. Port 1 is to be connected DB0 to DB7, and this is my RS, RW enable which are connected to pin 2.5, 2.6 and 2.7. So we will be connecting it to the LCD. First of all, RS, RW enable. Now connecting port 1. Now connecting the power supply. As you can see, this is the power supply. 12 volt ground plus 5 volt. First is connected to ground, second is connected to VCC, and third is your contrast. Now after connecting the LCD with the board, that is with the port P1, RSRW enabled with P2.5, 2.6, 2.7 and power supply, we will be connecting the board with the programmer. This is our programmer. Now connecting the board with the laptop. From the programmer, we will select the load file and start uploading. Then uploading is done. So this is our reset switch. When we press the reset switch, we will see the output from India, which is programmed in 89S52 for this to be displayed.